Imagine a perfect summer day, sunshine warming your skin, birds chirping overhead, and families gathered for a picnic on the soft green grass. Everything feels calm, peaceful, and safe, as if nothing could possibly go wrong. But then, without warning, the sky darkens. Ominous clouds roll in, and a violent gust of wind tears through the park, toppling trees and sending debris flying in every direction. The peaceful scene is instantly transformed into chaos. In just a few minutes, it's all over. The storm passes as quickly as it arrived, leaving behind a trail of destruction, broken branches, scattered belongings, and stunned people trying to make sense of what just happened. You might think it was a tornado that caused this sudden devastation, but it wasn't. The damage looks similar, but the cause is very different. What you just experienced was a microburst, a sudden, powerful downdraft from a thunderstorm that strikes with little warning. Microbursts are compact columns of sinking air that slam into the ground and then spread out in all directions, much like dumping a giant bucket of water onto the floor and watching it splash outward. These blasts of wind can reach speeds of over 100 miles per hour, causing severe damage to buildings, vehicles, and power lines in just seconds. For years, pilots and scientists were mystified by these invisible wind events, struggling to understand what was happening in the skies above. Microbursts are especially dangerous for airplanes during takeoff and landing, when sudden changes in wind speed and direction can be catastrophic. That's why understanding microbursts is crucial, not just for meteorologists, but for everyone's safety on the ground and in the air. Today, we'll explore how microbursts form, why they're so powerful, and what really happens when an airplane encounters one of these hidden dangers. By the end of this journey, you'll see weather and its hidden dangers in a whole new way, with a deeper understanding of the forces at play. Let's dive into the science behind the unseen storm and uncover the secrets that lie within the clouds. So, what exactly is a microburst? You might have heard the term on the news or from pilots, but what does it really mean? It's a small but incredibly intense downdraft that bursts out of a thunderstorm. Imagine air rushing downward at astonishing speed, almost like a waterfall of wind. When this powerful air slams into the ground, it doesn't just stop. It spreads out rapidly in all directions, creating a sudden blast of straight-line wind that can catch anyone off guard. Microbursts usually affect areas less than 2.5 miles wide, but don't let the micro in the name fool you. They can be just as destructive as weak tornadoes, packing a serious punch. These fierce winds can snap trees like twigs, rip roofs off buildings, and pose a major threat to aircraft, especially during takeoff and landing. The entire event is over in a flash, usually lasting just 5 to 15 minutes, but the damage can be long-lasting. There are two main types of microbursts: wet and dry, each with their own unique dangers. Wet microbursts come with heavy rain. You'll often see a dramatic curtain of rain pouring from the cloud, signaling the danger. Dry microbursts, on the other hand, happen in drier climates. Here the rain evaporates before it hits the ground, cooling the air rapidly and causing it to plummet even faster. The key thing to remember is that microbursts create straight-line wind damage, not the twisting, rotating winds you see with tornadoes. Picture a giant, invisible foot stomping down from the sky. The air rushes outward in all directions, flattening everything in its path in a matter of seconds. Microbursts are brief, incredibly powerful, and often arrive with little or no warning, making them especially dangerous for pilots and anyone caught outside. Understanding the basics of microbursts is the first step to respecting their power and staying safe during severe weather. They're a fascinating yet dangerous piece of weather science that continues to challenge meteorologists and aviators alike. So, let's dive deeper and see how the atmosphere cooks up these explosive storms. Stay alert. The next scene reveals the recipe for chaos and why it's so important to be prepared. How does a thunderstorm create a microburst? It's all about temperature and air movement. Start with a thunderstorm. Warm, moist air rises, cools, and forms clouds and rain. Sometimes dry air mixes in from above. As raindrops fall through this dry layer, they evaporate, cooling the air around them. Cold air is heavier, so it sinks fast, accelerating toward the ground. Rain and hail drag the air down even more. When this dense cold air slams into the ground, it spreads out violently. A microburst is born. It's a chain reaction. Rising air, evaporation, cooling, and a sudden powerful downdraft. Microbursts aren't random, they're the result of specific atmospheric conditions. Next time you see a towering thunderstorm, remember the powerful engine inside. Now let's see what happens when a plane meets this force. Airports and airplanes are especially vulnerable to microbursts because of wind shear, a sudden dramatic change in wind speed or direction that can occur without warning. These powerful bursts of wind can turn a routine landing into a life-threatening situation in just moments. A microburst creates extreme wind shear in seconds, unleashing chaotic air currents that challenge even the most experienced pilots. Picture an airplane, on final approach to land, descending steadily toward the runway as the crew prepares for touchdown. As it nears the runway, a microburst suddenly hits nearby, sending powerful gusts swirling across the approach path. First, the plane encounters a strong headwind, helpful at first, giving the aircraft extra lift, and making it seem like the landing will be smooth. The pilot may reduce power to stay on course, adjusting the throttle to compensate for the increased lift, and maintain a safe descent rate. Suddenly the plane enters the core of the microburst. A violent downdraft pushes it down, causing the aircraft to lose altitude rapidly. Then, just as quickly, the wind shifts to a tailwind, robbing the wings of lift and causing the plane to lose speed and height alarmingly fast. In seconds, the plane goes from climbing to sinking dangerously, with the ground rushing up to meet it and warning alarms blaring in the cockpit. The pilot, having just reduced power, now faces a sudden loss of airspeed and altitude, forcing them to react instantly to avoid disaster. This rapid sequence can be catastrophic, especially close to the ground where there's little time or space to recover from such a dramatic loss of control. Microbursts can turn routine landings into terrifying emergencies, putting everyone on board at risk in a matter of seconds. That's why understanding and detecting them is so critical for aviation safety. Modern airports rely on advanced radar and wind shear detection systems to warn pilots in time. Next, let's break down exactly what happens to a plane in wind shear, and how pilots fight to regain control. Buckle up, it's a wild ride, and understanding it could make all the difference. Let's break down a plane's flight through a microburst, step by step. The plane approaches the runway just a few hundred feet up. Suddenly it hits a headwind, extra lift, so the pilot reduces power. Next, the plane enters the downdraft. An invisible wall of air pushes it down fast. Alarms sound. The plane loses altitude rapidly. Instinct says pull up, but the downdraft is relentless. Then, the plane exits into a tailwind. Airflow over the wings drops and lift vanishes. Now the plane is sinking with less power and less lift. The pilot must react instantly. Full power, nose up, but avoid stalling. It's a split-second battle against physics. Microbursts can turn a safe landing into a disaster in moments. That's why pilots train for these scenarios and why detection is so important. Next, let's see where and when microbursts are most likely to strike. Awareness can make all the difference. Stay sharp. The next scene is about spotting danger. Let's go. Microbursts are most common in spring and summer, when thunderstorms thrive on heat and humidity. Peak season in the northern hemisphere is May through August. Think hot, stormy afternoons. Geographically, they can happen anywhere with thunderstorms, but some places are hot spots. The high plains, Colorado, Wyoming, New Mexico, see many dry microbursts due to dry mid-level air. Wet microbursts are frequent in the humid southeast, Florida, Georgia, the Gulf Coast, where heavy rain drags air down. Most microbursts occur in the afternoon and early evening, when the sun's energy is highest. Watch for rapidly developing dark-based clouds, your cue that the atmosphere is primed. If you're in a microburst-prone area, stay weather-aware from 2 to 8 p.m. Spotting the signs can keep you safe. Ready for a quick quiz? Let's test your microburst smarts. Time for a microburst quiz. Can you spot the warning signs? Scenario 1. Hot afternoon. Isolated thunderstorm. Curtain of rain that doesn't reach the ground. Dust spreading out. Microburst? Yes. Classic dry microburst. Scenario 2. Cool, overcast day. Light drizzle. Gentle wind. No thunder. Microburst? No. No thunderstorm. No energy for a downburst. Scenario 3. Thunderstorm approaches, cloud base bulges downward, then a shaft of heavy rain and hail drops. Microburst? Absolutely. A visual sign of a wet microburst forming. Recognizing these clues can help you stay safe. Microbursts often give subtle warnings, if you know what to look for. Stay alert, especially during stormy weather. Next, let's see how technology and training help us fight back. Science saves lives. Let's see how. On to the next scene. Microbursts led to a revolution in weather detection and pilot training. Terminal Doppler Weather Radar, TDWR, at airports now detects wind shear and microbursts, alerting controllers and pilots instantly. This technology has nearly eliminated wind shear-related accidents in the US. Modern aircraft also have onboard wind shear detection, warning pilots before they enter danger. Pilots train extensively in simulators to handle microburst encounters, reacting fast, applying full power, and climbing away. Science, technology, and training have turned a deadly mystery into a manageable risk. We can't stop microbursts, but we can outsmart them. The result, safer skies and better weather awareness for everyone. That's the power of science in action. Let's wrap up with why this knowledge matters. Microbursts are a dramatic reminder of the power of our atmosphere. Understanding them isn't just for pilots, it's for everyone. Recognizing the signs can keep you safe and aware. Scientific literacy empowers us to make smart decisions in the face of nature's surprises. The story of microbursts is also a story of human ingenuity, using science to solve real-world problems. Every safe landing in stormy weather is thanks to decades of research and innovation. Next time you see a towering cloud, remember the forces at work inside. Microbursts are more than just wind. They're a lesson in physics and the value of understanding our world. Even invisible forces can be predicted and respected through science, and that's pretty cool.